Welcome to today's lesson. I am Siamasaka Kirian Dennis, and so I'm going to take you through the lesson for today. Well, as I indicated, today we are going to look at waves, and the type of waves we are going to look at electromagnetic waves. We are aware that we have electromagnetic waves, and they are actually ordered according to the wavelength. This is very important, as well as the frequency. So they come in a certain pattern because of the differences in wavelength as well as frequencies. And therefore, because of this arrangement, we come up what is known as the electromagnetic spectrum. It becomes a spectrum of aligned electromagnetic waves according to the wavelength as well as the frequency. They are basically created by oscillating magnetic and electric fields. This is important because of the oscillating magnetic fields as well as electric fields, and so we come up with these electromagnetic waves. They are transverse in nature, meaning that the vibration of the particle in there is actually perpendicular to the progression of the wave. So all the characteristics of transverse waves actually apply to electromagnetic waves. So the accelerated charges are the ones actually which produce actually electromagnetic waves, and they have a constant velocity, and mainly in their propagation, electromagnetic waves do not require actually media. They can even actually move in a vacuum where there is nothing at all. So the change in frequency will not actually occur as they propagate. Electromagnetic waves can be interfered with. They can also actually penetrate through corners by diffraction. They can as well be actually reflected, and they can also be polarized. Well, this is actually a spectrum showing electromagnetic waves. We have X-ray, we have gamma rays, then we have X-rays, we have ultraviolet light, we have infrared, we have microwave, we have radio waves, which we have actually FM, as well as AM, as well as the long radio waves. What's to note here is that the frequency increases in this direction, as you can see. You notice that actually gamma rays have very high frequency when you compare to actually radio waves. Similarly, down here you notice that actually the progression of the wavelength increase is on this manner we see shown. You notice that here the gamma rays have very short wavelength compared to radio waves. And in between here, this is where we have actually visible spectrum in between. So this is very important because you need to always know exactly the pattern. In examinations, normally they would want you to know the exact pattern of the electromagnetic spectrum. That is, you need to know exactly the position of each of this electromagnetic wave. It's important also to know actually the sources of these electromagnetic waves. For example, radio waves, actually their main source is the electrical oscillating circuit, while microwaves are actually produced by an oscillating charge in a microwave or transmitter. Then the infrared is actually produced by hot bodies. Visible light is actually produced by the sun, fire, and the other hot bodies. Ultraviolet light is produced by very hot bodies, mercury vapor lamps, and X-ray is produced by X-ray tubes. Gamma rays are produced by radioactive actually substances. So these are mainly the main sources which actually produce electromagnetic waves. And as I indicated, it's very important to know the position of each electromagnetic wave depending on the wavelength as well as the frequency. And so these electromagnetic waves have several uses. For example, radio waves, we use them for telecommunication, as well as broadcasting, as well as in astronomy. While microwave electromagnetic waves, we use them for satellite transmission, cooking, and the radar system. While infrared is used in heating, especially in physiotherapy, medications, also in remote controls. You see the remote that it has actually infrared. Thermal imaging, light vision, that is night vision, thermometers, as well as cooking. While visible light, we use it for sight, photography, also for photosynthesis. Ultraviolet light is actually used to provide vitamin C, vitamin D production, sterilization, pest control, and fluorescent effects. Actually, if you want vitamin D, you may expose yourself to sunlight, and then it means that vitamin D will be produced. X-ray is actually used in radiotherapy, or you want to determine the cracks. You can easily actually detect the cracks using the X-ray. So gamma rays are used for treating cancer, as well as sterilizing medical equipment, as well as pest control in agriculture. Also crystallography, we use also actually gamma rays. So I thought today we can look at electromagnetic waves, what they are, their origin, what produces them, as well as where they can be used. And the most important thing I've mentioned is that actually electromagnetic waves have a spectrum, which is as a result of differences in the frequency as well as wavelength. And so this pattern is very important because it is frequently asked even in examinations to really identify the exact place where each of these electromagnetic wave is placed, depending on the increasing frequency as well as the wavelength. It's important to know that, as I indicated, that the electromagnetic waves have actually, in a vacuum, they have a constant velocity, which is 3 times 10 to the power 8 meters per second. So many times questions are asked to really identify the speed of actual electromagnetic waves in a vacuum, which is actually 3 times 10 to the power 8 meters per square seconds. I thank you.